Hello everybody, and welcome to exercise 6 on page 22 of the workbook. Let's take a minute to read this question together. So the temperature in degrees Fahrenheit on a winter day in Rapid City, South Dakota is given by values of the function f of t, where t represents number of hours after noon. Values of the function are given in the table to the right. So this is a table that's telling us the temperature at various times. Now here's what they'd like us to do. We want to estimate the value of f prime of 1 and then to give an interpretation of that number. Okay, so I'd like to start with just a rough graph of this. Okay, they don't give it to us, but we can just draw a nice little scatter plot of this data. Okay, this is going to be a very rough picture. Okay, so we're talking about input values of t, so time in hours, and then our outputs are temperatures. All right, and let's see. Our time scale is going to 5, so maybe number 2, something like that. And then temperature, maybe we'll go up to 20 on this scale. So again, what we're looking for here is just a very rough picture. Okay, I'm going to plot these points one by one. So starting with 0, 5, that point would be about here. And then 112, maybe that's about here. 215, 318, 417, okay, and then 514. Okay, and then, actually, wait a minute. Okay, again, this is a very rough picture that I'm drawing. Okay, so if we just kind of play the connect the dots, I'm going to draw just a very rough curve. Okay, so you can think of the temperature as sort of going along this curve. All right. Okay, now, how do we do this estimation that they're asking us to do here? Well, remember what f prime of 1 represents again. That's the derivative at 1, which graphically is the slope of a tangent line. So what they're asking us to do is to estimate the slope of this line that I'm drawing, and I'm going to call it t for tangent. Okay, but how do we do that? We don't have a formula for our function, and all we really have is a bunch of points looking up at our table here. Okay, so there are different ways to think about how to estimate this slope, but one way would be to ask yourself, could we use the data points themselves to estimate the slope of t? Okay, and if you think about it a little bit, these 2 points on either side of 1, 0 and 2, if you pick those 2 points and draw a line, notice that the slope of that line is reasonably close to the slope of t. Okay, I'm going to label it S because that's really a secant line that we're talking about, a line that goes through 2 points on our curve. And so our approach here is going to be to estimate f prime of 1 by just writing down the slope of the secant line S. Okay, notice the 2 points that it goes through are 0 and 2. So the slope of S would be f of 2 minus f of 0 over 2 minus 0. Okay, and we can see what f of 2 and f of 0 are in our table. F of 2 is 15 and f of 0 is 5. So we'll subtract those two numbers. Okay, divide by 2 minus 0. And if we do the arithmetic there, we've got a 10 over 2, which is a 5. Okay, so there's the numerical estimate of the derivative. Now the question is, what does it mean? Okay, well, let's think units here. So that's an estimate of the slope of the tangent line t that we're looking at here. So the units should be units of rise over run, meaning that we should be getting degrees Fahrenheit per hour as our units. Okay, so you can think of that 5 as just representing our best estimate of the rate at which the temperature is changing at t equals 1 hour. Okay, tells us that it's increasing at a rate of about 5 degrees Fahrenheit per hour at t equals 1, that's our time. And notice that in the problem they said t represents the number of hours after noon. So t equals 1 would actually represent 1 p.m. Okay, so we could put a clock time to it and say that that's the rate of temperature increase at 1 p.m.